In this lesson, students use what they know about geometric transformations to explore transformations of linear functions on the coordinate plane. On day one here, we have outlined our objective and our success criteria. We'll be translating linear graphs horizontally and vertically and using transformations to graph linear relationships. We have a star warm-up here. So this is how this skill is going to connect to star. Actually, this particular star warm-up was a review of a previous skill, 8.4b, which looks at unit rate on the coordinate plane. And then for getting started, we're going to take some time to remember what did we do with transformations at the beginning of the year? What are the rules that we discovered and how did we use them? And here's a reminder of the rotation rules that we've added to these slides for the students. So we have a chance to revisit reflections, we have a chance to revisit rotations, and the last slide had translations. We'll look at dilations as well, and students at this point are probably wondering, we already did this. Why are we talking about transformations on the coordinate plane? And the reason is because it builds an understanding for transformations of linear functions, which is what we're going to look at next. Some questions that we're looking at are, how does the slope of a line change as you move the line up and down the y-axis? Does it change? How do the coordinates of the line change as you move it up and down the y-axis? So this is an exploration students are going to engage in. They'll see graphs of parallel lines. That would be lines that have been translated up or down the y-axis. And they'll be looking at the slopes of those lines and their coordinates. There is a check for understanding, a turn, talk, and share out embedded within this lesson. And we'll also be using tables to help them organize their thoughts so that they can make discoveries. The exit ticket for today asks students to explain how to use transformations of the basic equation y equals x to graph the equation y equals mx plus b. And of course, to do that, first, they're going to need to dilate by multiplying x by m, and then they're going to need to translate vertically or horizontally by adding b. At this point, we have a short assignment for them. They should be able to draw similar triangles on the graph to determine slope. And we have a closing activity in which they reflect on their understanding of the success criteria thus far. Day 2, once again, has our objective and our success criteria and a new star warm-up. Day 2 has more opportunities to explore transformations of linear functions. As you can see here, they're looking for relationships between these equations and how those differences are reflected in the graphs of those equations. In this example, students look at both dilation, a dilation of the line, which changes the slope, and a translation, which changes the y-intercept. There is an assignment embedded directly in this lesson for students to work with. There are practice problems and review problems listed here. And before leaving class today, students will have a chance to summarize their learning in exactly 7 little words by working with a partner to use exactly 7 words to say what it is they learned. Finally, before they leave the classroom, we'll tie a bow on this lesson with one more star problem and a reflection on our progress towards those success criteria.